Oh, okay. So we're doing lesson 1.5, measuring angles. We're going to be learning how to apply the angle addition postulate. We're going to be learning about congruent angles, and on top of that, we're going to be learning about angle bisectors. So the angle addition postulate. The angle addition postulate states that the sum of two smaller angles, these guys right here, on the interior of an angle equals the bigger angle. What? Listen, I'm a visual learner, so let's highlight this. And if you have a highlighter, you should be doing this too. What this is saying is the two interior angles, x, w, y. These are the two smaller angles, okay? X, w, y, and y, w, z. Okay, these are our two smaller angles, are going to equal this bigger angle, x, w, z. All right, so let's write that out. X, w, y plus w, y, w, z is equal to x, w, z. X, w, z. Now, you might be wondering what this m is doing there. That m means the measure of, okay? In degrees, okay? The measure in degrees. So the measure of this angle plus the measure of this angle equals the measure of the bigger angle. Now, if that's not making any sense, think of a pizza. If I have this slice of pizza and this slice of pizza, and I put them together, I get the bigger slice of pizza. Got it now. Okay, so let's write the angle addition postulate for this set of angles right here. So what we have is angle QRS, okay, angle QRS plus SRT, all right, plus angle SRT is equal to the bigger angle, QRT, angle QRT. Let's highlight it just because it helps out to visualize. QRS, okay, that's this guy, plus SRT, remember vertex is always in the middle, equals our bigger angle, QRT. Ooh, it's like a rainbow. It's so pretty. Let's try this again. Let's start with highlighting this time. Just switch it up. Now this angle, the smaller angle, QHP, that's going to go right here, plus PHQ, which is going to go right here, is equal to the bigger angle, this big one right here. Let's write it out in pen now. Let's get some angles going. So angle QHP, QHP, plus PHG, angle PHG, all right, is equal to this bigger angle, QHG, angle QHG. All right, let's use the angle addition postulate to do some problem solving. To start, we know that the measure of KLB is 26 degrees, and KLB is this guy right here, okay? And I'm just going to put a little mark there. And it's 26, so what we should do is probably fill that in, okay? Because the first thing we're going to do when we're solving a problem is fill in the angle measures. So this is 26 degrees. Great, awesome, we know something. Second, we know that the measure of BLM is 60 degrees. Well, let's track down BLM. BLM, where are you? You're right here, BLM. And you are equal to how many degrees? 60. We're trying to find the measure of KLM, right? That's the bigger one. So let's just highlight the bigger one for you. We're trying to find KLM. And that will go, the bigger one always goes there. And I forgot that. So how do we solve this? Well, first thing you always do after filling in the angle measures is to write out the angle addition postulate. All right, we got that done. Now let's write out the angle addition postulate. And we know the two smaller angles, which is KLB, look at the yellow, plus the angle BLM, right, look at the purple, is equal to the bigger angle, which is angle KLM. From here, once we've written out the angle addition postulate, we substitute the angle measures. KLB is equal to 26 degrees. BLM is equal to 60 degrees. And KLM is what we're looking for. So what we'll do is just add up these two angles. We get 86 degrees, and boom, we know what the angle KLM is equal to. And that makes sense. 26 plus 60 equals 86, which is the whole angle. We just did it. All right, let's try a different kind of question, okay? Now for this one, we know that the measure of XWZ is equal to 121. And XWZ is actually the bigger angle. That's what it's giving us, all right? So the bigger angle is what it's always equal to, and that's equal to 121. And let's put that on the outside. Now what we also know is XWY is 59, and XWY, oh, let's change colors, is right over here, and that's 59 degrees. Finally, what we're looking to find out is this guy, YWZ, and that's what's going to go over here. So let's fill in the angle measures. Sorry, we did that. We got to fill in the angle measures on the drawing. 2, we're going to write out the angle addition postulate. So we know the two smaller angles, which is the yellow, or XWY, plus angle YWZ is equal to the bigger angle, which is angle XWZ. From here we substitute the values in. So we know that number XWZ is 121, that goes over here. We know angle XWY is 59 degrees, which is over here. And what we're trying to find is this. We're trying to figure this out, so we don't know anything about it. To solve this, well, we're going to have to subtract 59 degrees from both sides of the equation. We're subtracting 59 degrees. And what that gives us is angle YWZ, this cancels, is equal to 62 degrees. And let's see if that makes sense. YWZ is right here. YWZ, that's 62 degrees. If we added these two together, 62 plus 59, does that equal the bigger angle? Yeah, it does. So that makes complete sense. Okay, finally, it's our last example. What we know is that the measure of OMN is equal to 7x. Okay, OMN is right here, and that's 7x. And like we said, we always fill in the information we know. We fill in the angle measures on the drawing. Let's do that. OMN is 7x. The second thing we know is MNL is 12. So NML, which is right here, is equal to 12 degrees. Fill that in. And finally, OML, which is our bigger angle, OML is equal to 68. And let's put that on the outside so we know what it is. All right? And that's what we filled in our angle measures. Perfect. We got that done. 2, write out the angle addition postulate. So we know that angle OMN, okay, that's this angle right here, plus angle NML, that's the smaller angle, is equal to the bigger angle, OML. Angle OML. Good. We wrote out the angle addition postulate. Well, from there we substitute the angle measures. So we know OMN is 7x. We know NML is 12 degrees. We get that from over here. And we know OML is 68 degrees. Now we just have to solve this. Now, as I always say, if you know how to solve it, go for it. You can move on, fast forward the video, and do it on your own. If not, I can help you out a little bit. So we're going to put our variables on this side, our constants on this one. First thing we have to do is move over the 12, right? Because we start with addition. So let's subtract 12 from both sides. All right? When we subtract 12 from both sides, the 12s cancel, and we get 7x is equal to, well, 68 minus 12 is equal to 56. All right? From here, we got to do the opposite operation to move this 7 over. So the opposite of 7 times x is 7 divided by x. We divide both sides by 7. This cancels, and we get x is equal to 56 divided by 7, which is 8. We frickin' did it. Done. All right, next problem. Whew. Oh, I see what's going on here. I see what the deal is. All right? It's not that. Hold on. Hold on, I got this. Just gotta move this here. All right, congruent angles. Let's do a little quick talk about that. Congruent angles are angles with the same measure, okay, in degrees. We use marks to show angles are congruent. Now this is like with the congruent segments, we use marks. Angles, we don't use lines, we use these, okay? So if you look, these have these little lines that tell us that these two angles are congruent. So if this was 60 degrees, this would be congruent, or the same measure, and also have 60 degrees. These two don't have the same amount of lines. This has 2, this has 1, so they are not congruent. So this would be like 60 degrees, and this would be like 30 degrees. This is actually up 2, so it's probably, whatever, okay. So we're going to mark the following angles. Angle B is congruent to angle E. The way to do this, well, it's pretty straightforward. Boom, boom. That means they're congruent. If I want to get a little fancy, I could do even 2, as long as they both have the same thing. So these both are congruent. Number 2, list the congruent angles and sides. Okay, well, let's look at this. I know about sides, so I know that XY, okay, XY is congruent to XZ. These two segments are congruent. I also know that this angle, angle Y, is congruent to angle Z, right? Because they have the same marks. And angle X, well, nothing else has 2 marks, so it's not congruent to anything, and that's it. We did it. Now we're going to mark the trapezoid with the following information. So follow me. AB, which is over here, is congruent to CD. So AB is congruent to CD. Awesome. Angle ABC, so let's highlight that just to make it a little easier. ABC, the vertex is in the middle, is congruent to BCD. All right, BCD, vertex in the middle. So let's just mark those 2 angles. This one, ABC, is right here, right? The vertex is in the middle, ABC. And BCD, right here, the vertex is in the middle. These 2 angles are congruent. And finally, AFB, vertex in the middle, AFB, that's this angle, is congruent to DEF. DEF, vertex is in the middle, and that's going to be this guy, DEF. Wait, DEC. Let me change that on you. Boom. All right, guys, that's all marked up beautifully. Let's move on. Angle bisectors. Remember, what does the word bisect mean? It means to cut in half, right? A bisector cuts an angle into 2 congruent angles. It cuts it right in half. So let's see. If JK, this angle right here, this line right here, ray JK bisects LJM, then I know that it cut this in half, or 2 congruent angles. This would be angle LJK, that's in the yellow, LJK is congruent to KJM, angle KJM. So if I know LKJ is 30 degrees, right, then I know the angle KJM is also 30 degrees, right? They're congruent. Think of it like a slice of pizza. Let's say I took this bigger slice of pizza right here and I cut it in half. If this had 5 pepperonis, then this would also have to have 5 pepperonis. Though it doesn't work like that in real life. When you cut something in half, it has equal amounts on both sides. Alright? And just like this has 30 and 30. They are congruent. Okay, let's use that to solve some problems. If KM bisects JKL, KM bisects JKL, and we know the measure of JKM is 20 degrees. So JKM is right here, and it's 20 degrees. Determine the measure of MKL. So first we write our congruent statement. Because we know KM bisects this angle, we're going to say that JKM, angle JKM, is congruent to MKL. Alright, angle MKL. It cut it in half, so this is congruent to this. Now I'm going to substitute my value. So if I know JKM is 20 degrees, I know that the measure of MKL also has to be 20 degrees. And it's already solved for us. And let's see if that makes sense. Well, if this is 20 degrees, this also must be 20 degrees because it's been bisected. Easy, done, we're the best. Challenge problem. We know QS bisects PQR. That's the bigger angle. PQS is 4x plus 24. Now, as we know, we must label when we read. So this is 4x plus 24. And SQR, which is over here, is 7x. We want to find what is the angle PQS. Now to do that, we have to find out what x is. So, we filled in our angles. Now we got to write our congruent statement. Let's start there, okay? So we know that angle PQS, this angle right here, has to be congruent to angle SQR. Why? Because if this is the bisector, that makes this congruent to this. And I should have done that on this too. This is congruent to this. Alright? What we have to do now is substitute our values. So PQS is 4x plus 24. And we know SQR is 7x. Alright? Just substitute our values. Now we solve. If you know how to solve, go for it. If not, check it out. What we're going to do is put these lines. Now this side has numbers on it, and this one just has number and variable. So we're going to make this our variable side and this our number side. So to move the variable to this side, to the variable side, what we have to do is use the opposite operation. And since this is a positive 4x, we have to subtract 4x from both sides. Alright? We have to minus 4x from both sides. This cancels and we get 24 is equal to 3x. Now to solve it, this is 3 times x, and to bring this number to the opposite side, we have to use opposite operations, so we're going to divide both sides by 3. Boom. And we get x is equal to 8. Well done. Now that's not what the question's asking us though. We just solved for x. What we're really trying to find is the measure of PQS. Well, what we're going to have to do is substitute x in for PQS. Now we know the measure of PQS, alright, is 4x plus 24. To find what this measure of this angle is, we have to substitute x with 8, right? Because we know x is equal to 8. We do 4 times 8, which is 32, alright, degrees, plus 24 degrees. And so that means the measure of PQS is equal to 56 degrees. We did it! We got to the end of the lesson. 17 minutes and 42 seconds later. Thank you for sticking with me. You are awesome. Remember guys, math is life, and don't kick cats.